we're going to start with the isomers as well. We're pretty much done with naming, so we'll just practice a few more questions related to naming of organic molecules, and I'm just going to do let's do one more. We did one, so let's try and apply all the rules to another one. So let's say I've got carbon atoms, and there's a carboxylic acid, and it's got a ketone, plus there is a double bond as well, and then you have maybe a carbon chain. Let's add another carbon chain, and there's an OH as well. Let's make it as complicated as possible, and this one will have one hydrogen. This one over here will have 3 hydrogens. This one will have 1 H. This one will have 3 H's, and so on. So you've got this carbon atom. So the rules were that you look for the main chain first. Everything is secondary now. The main chain has to be found out. Which one is the main chain? And the rules for the main chain were that it should be the longest possible. I mean, we wrote down all the rules somewhere. What's the main chain? Where's the main chain? This one. So it should be the longest possible carbon atom chain that follows the following rules. That it should contain the highest, most important group. It should contain double bonds, and it should contain the maximum number of substituent groups. Like maximum things must be attached to the main chain, especially the highest presence group. And the main chain is going to be named after the suffix of the highest presence group. Everything else, the rest is all branches then. So if I go back, apply this over here. In this case, I think it's the carboxylic acid, which is the highest presence group. So our main chain, our longest possible carbon atom chain is going to be, this one. So it's going to be this one. Because this chain has the carboxylic acid group, it's got the double bonds as well. The OH is also attached to it. The ketone is also attached to it. The alkyl branches are also attached to it. So that's a good choice for the main chain. And you're going to number the main chain to give, I mean, the most important group. This one is the highest precedence group, carboxylic acid. We had a precedence order. So this one has the highest precedence. So you're going to start numbering it based from this point. This is 1, this one is 2, this one is 3, then you have 4, and then you have 5. So it's 1, 2, 3, 4, 5, and that's the main chain. And you've got 5 carbon atoms. So the main chain is going to start with pent. Is it going to be AN or EN? Okay, what is
EN hoga.
This is going to be EN because you've got an alkene, and it's going to be oic acid because it's a carboxylic acid. It's going to be an oic acid because it's a carboxylic acid, but at the same time it's also a ketone. Remember I told you that the ketone always remains a suffix. Where's this? So I told you that if a molecule is a carboxylic acid, but at the same time it's also a ketone, you're going to have 2 suffixes. The alcohols and the amides, you have a choice that changes into a hydroxy branch. But just one second. Just hold on 1 minute. Give me 1 minute. Sorry, just one sec. Can you guys hear me? Hello?
Yeah, we can hear you.
Yes, sir.
Acha. I just remember, okay, just this is probably just the last one. We're going to finish this. So just remember, okay, a ketone would always remain a suffix. So what you're going to do is, okay, it's going to turn into, you're going to add another suffix, which is the ketone suffix. So the molecule is going to have two suffixes. It's going to have oic acid, it's going to have one as well. And you're going to write the positions. For the carboxylic acid, there's no need for writing the position. It's always position number 1. On is going to be, it's going to be 3. And the other one, the double bond, is at position number 4. Now that's your main chain. Everything else now becomes a branch. Everything that's not part of the main chain, that is now a branch, and that's this one. The OH also becomes a branch. So you've got that's it. The 3 branches. So there are 2 methyl branches. So it's methyl, and there are 2 of them. So it's going to be dimethyl. And there's a hydroxy branch. The OH is a hydroxy branch. So that's your. So that one is your hydroxy branch. Yes.
सर वो आपने कहा था कि कोई ऑर्डर होती है, लाइक कंफ्यूज हूँ, क्या वो डाउट था कि कौन सा ऑर्डर आप कह रहे थे इसका?
branches जो है ना, they would be written in alphabetical order. So M and H. I mean, forget the di. Di is just for telling you that there are 2 branches of methyl, and methyl. M comes after H. So H comes first and methyl comes later. Okay? So the branches are written just in alphabetical order. That's one branch, and that's the other branch. And you're going to write the hydroxy group is at, there's only one, right? So the hydroxy group is at position number 5. And the methyl groups are at position 2 and they're at positions 2 and 4. Is that clear? Is this clear, this thing?
Yes, sir.
Okay, so there's this clear, I'm clear.
Yes, sir.
Okay. So we're going to continue. We're going to continue naming. We'll do other molecules and we're going to try and name those molecules. But this is the main idea of naming molecules. Remember, direct questions are not going to be that important. Just 1 or 2 mark questions on naming. But indirectly, it would matter. So I'm going to move towards isomers now, and we will continue naming molecules as we go on. We'll continue practicing this. So I'm going to move towards isomers, and isomers. So what are isomers? Isomers, I mean, the basic idea of an isomer is that if you have a molecule, I said, remember why isomers are important. There is a reason why isomers are very important, because remember, a lot of chemistry is just guesswork. When you talk about molecules, like, I mean, the structure, like if you look at this structure, no one has actually seen this structure. It's you've got multiple analytical techniques to figure out what the molecule looks like. Like if you talk about a glucose molecule, you can't just go on and zoom in and look and take a picture of the molecule. What you get is bits and pieces of information about the molecule. And you combine those bits and pieces of information from various analytical techniques, which we will do some of them, and you try to figure out what the structure is. So isomers come in handy because the first information that you get about a molecule is, like if somebody is researching on COVID virus, the first information they're going to get is that how many atoms it's got. It's got, so for example, if you got 4 carbon atoms and 10 hydrogen atoms, then you're going to start doing some guesswork. As a scientist, what you'll do is you'll try to figure out like how many different possible arrangements could there be. So maybe the 4 carbon atoms are arranged in this order in a straight chain, and all of these are hydrogen atoms. So that's one. Or the other one is maybe the arrangements, the carbons are arranged in this manner. So they are all possible arrangements that are possible. In this case, they're just 2. So maybe so maybe the hydrogens are arranged in this order. So there's going to be a lot of guesswork going on. And then they'll try to figure out, like the scientists will try and figure out that if this is the molecule or this is the molecule, there's going to be a difference in properties. So they would test out the properties, like they will check what the physical properties are, they'll check what the chemical properties are. If the structure is different, they're going to behave differently. So they're going to do lots of chemical and physical tests on it. And then they'll try to figure out, maybe it's this molecule, maybe it's this molecule. So the first information that you get about a molecule is the number of atoms. And then you try and figure out what type of structure would this have. So the structures are kind of like guessworks. They're intelligent guesswork, but at the end of the day, you're basically trying to guess what the structure looks like. So that's where isomers come in very handy. They try to they're very useful in analytical chemistry. You'll probably study analytical chemistry, and you'll need the help of isomers, especially when you're trying to figure out what the structure of a molecule looks like, especially in A2. Okay, is the idea clear why isomers are important?
Yes, sir.
Yes, sir.
As the first one, the old one, there are 2 types of isomers. One of them is your structural isomers. So you've got structural isomers. Structural isomers, the definition of a structural isomer is the ones that I just drew, that those are structural isomers. Structural isomers are your O-level isomers. You have the same molecular formula. So it's molecules having similar molecular formula and different structural formulas. Now, what we mean by different structural formulas is it's going to be a different arrangement of atoms. The atoms would be arranged differently. They're going to be bonded differently. So that is what a structural isomer is. And this one is one example. Like, they have exactly the same number of atoms, but they are definitely arranged differently. And then there's another type of isomer which is known as a stereoisomer. That's the second one. The second one, the definition of a stereoisomer is now a stereoisomer is that it has the same molecular formula. So it has the same molecular formula, and it also has the same structural formula. Even the arrangement is exactly the same.
सर
हाँ जी,
सर ये वही है ना जो इसको बायो में पढ़ा था कि उसके अंदर लाइक H और OH का डिफरेंस आ जाता है डिफरेंट कार्बन्स पर.
नहीं stereoisomers में I'll explain. ठीक है, we'll talk
Yeah.
about this in detail. नहीं, that's not exactly in that way. We'll discuss that in detail. ठीक है, we'll discuss this with examples. So I'll just write down the definition first. Same molecular formula, same structural formula. So that means the arrangement is exactly the same, but different. Three-dimensional space, different three-dimensional shape. And orientation of bonds in space. So orientation of bonds in space. So right now, I'll just give you a very brief overview of what I mean by this. I mean, look at your two hands. They are stereoisomers of each other. Your two hands, they're connected in exactly the same way. The fingers and the thumb are connected in exactly the same way. So the connections and the arrangement is exactly the same, but your two hands are different. They're different because the three-dimensional shape and the orientation is different. If you place your two hands on a table, your thumbs are pointing in opposite direction. So the orientation of the bonds in space is different. They look exactly the same. They are arranged in exactly the same order. The thumb is exactly attached on the same thing on both thumbs, but they're mirrored versions of each other. One thumb is pointing on the right side, the other one is pointing on the left side. So the direction of the bonds is different. So that is what a stereoisomer is. That's the idea behind a stereoisomer, that even the structural formula is the same, even the arrangement is the same, but the three-dimensional shape of the molecule and the orientation of bonds in space is going to be different. And we'll discuss this in a lot more detail, TK, just after this. Is the idea clear? Two types of isomers. Structural isomers, where the structure changes, the arrangement changes. And then you have stereoisomers, where the arrangement remains exactly the same. The three-dimensional shape is kind of different between the two molecules. Is the idea clear between the two?
Yes, sir.
And I'm just going to quickly write subtypes, and then we'll take a deep dive into this. The subtypes over here there would be three types of structural isomers. There's going to be chain isomers. And there's the part B is there's going to be positional isomers. And then you have a third type of structural isomer that is a functional group isomer. The questions can be very specific. They would just be asking about chain isomers or positional isomers or functional isomers, functional group isomers. And in the case of stereoisomers, there are two types. One of them is optical isomers. And the other one, part B, is a geometric isomer. This first one, optical isomers, has to do with the chirality, and the other one has got to geometric isomers have something to do with they're known as cis and trans, but we'll discuss that later. So we're going to focus on structural isomers first. Structural isomers are, that's one example. That's what a structural isomer is. So I'm going to start with chain isomers first, and I'm going to one by one do each one of them and describe each one of them. So chain isomers, part A, that's chain isomers. In chain isomers, you just alter the carbon chain. That's about it. So like without drawing anything, like if I have 5 carbon atoms in a straight line, forget any group that's attached to them. Let's say there are 5 carbon atoms, that's it. So how many different ways can I put those 5 carbon atoms? I can have one isomer would have 4 carbon atoms in a line, and 1 carbon atom would be as a side chain, as a branch. Or I can have 3 carbon atoms in a line, and there's going to be 1 carbon atom branch, 1 carbon atom, 1 carbon atom branch, right? So So that's known as a chain isomer. What I'm doing is I'm just changing or altering the carbon chain. I'm altering the arrangement of the carbon atoms. So you just change the carbon chain. That's one thing. Is that clear?
Yes, sir.
So that's number one. Just alter the carbon chain. And but you have to be careful when you're making an isomer. Make sure you know what an isomer is. The structure needs to be changed. Remember that these formulas, they're not the actual shape. The carbon could be pointing downwards. Even if the carbon is pointing upwards, it would still mean exactly the same thing. So I'm going to draw a fourth one. Let's say I draw a fourth one, and this one looks like this. That's again 5 carbon atoms. Do you think that's a different arrangement compared to the first 3 that I've drawn? Anyone, is it different or is it the same?
Different.
Okay, someone says this is different. Does it look? So I'm just going to tell you, this is not actually a different arrangement. This is actually exactly the same as one of these 3. Can you guess which one does it look like? As I think of it this way, like if you have your hand, I mean, you can point your fingers in different direction, but it's still your hand. Like, I mean, the direction of the bonds is not, it doesn't matter. It's the connections that matter. I mean, you can point your finger upwards, you can point your finger downwards, but it's still your hand. It's still, I mean, the finger is still connected at the same position. So can anyone guess which one is it similar to? This one, or this one?
The second one, the one below it, like the first chain,
Okay.
and then you drew the second chain, right? That one, yeah.
This one. So now this is very important because you need to learn what is not an isomer. It's easy to make isomers, but people, what they do is they sometimes make this mistake, and they often make this mistake that they can't identify what is not an isomer. These two, if you look carefully, these two are exactly the same. It's just a bent, rotated, or twisted version. So look what's happening here. It's 1 carbon atom, 2 carbon atom, and on the 3rd carbon atom, there's 2 carbon atoms attached, right? That's how the connections are. 1st, 2nd, 3rd one, there's 2 carbon atoms. Look over here, it's 1 carbon atom, 2 carbon atom. On the 3rd one, there's 2 other carbon atoms attached. So this thing kind of looks exactly the same. I mean, I can circle this. It's just a bent version of the first one. 3 carbon atoms, and on the 3rd one, there's 2 carbon atoms attached. That one is exactly the same, like 3 carbon atoms, and on the last one, there are 2 carbon atoms attached. So do they look exactly the same now? Is this clear? Mahat, Sidra, is this clear? Saim? So,
Yes,
Yes,
sir.
sir.
okay. So
सर
you,
वो
हाँ,
सर वो लाइक उसमें लीनियर चेन है, इसके अंदर एक तो कम से कम वर्टिकल तो है एक इसके अंदर.
नहीं, लेकिन I told you, kid, it doesn't matter which direction the bond points. Like this one, right? The C is pointing over here. If I make the C point downwards, like it's still the same thing. There's no difference, right? Is that clear?
Yes.
But if you have an arm attached to you, it doesn't matter where that arm is pointing. You can point it to the left side, you can point it in front of you, you can point it upwards, but it's the same thing. TK, do you get the point?
Yes, sir.
TK, so an isomer is formed when you rearrange things. Like you take off your arm and you attach it somewhere else. That's what an isomer is. TK, you have to rearrange things. If you're just changing the direction, that's not, and this is not the direction in the first place. This is not the 3-dimensional shape of the molecule. The actual shape of the molecule is, like in this case, it's going to be tetrahedral. So this is not the shape of the molecule to begin with. Is that clear? So So when you draw structural formulas, what you do is you just what you're just telling or drawing is the connections, like who's connected to who, which one. It doesn't matter if this C is pointing in this direction or if this C over here, if I pick this up and this C points over here, it's exactly the same. There's no difference. So these two are exactly the same. So remember this, that bent or twisted or rotated versions are not isomers. The rotated or flipped around versions are not isomers. They are not isomers. You have to watch out for this. So this one is an incorrect isomer. And people make a lot of mistakes when they're making structural isomers, at least. A lot of times they just make the same thing and they think that's an isomer. I mean, I'll do another.
सर वो फिर ब्यूटेन का जो एग्जांपल है वो भी तो रॉन्ग प्रूव हो सकता है जो साइक्लोब्यूटेन हमारे पास बनता है
क्या
लाइक ब्यूटेन के लाइक अगर हम लोग लीनियर स्ट्रक्चर ले और या उससे साइक्लोब्यूटेन और साइक्लोब्यूटेन का जो लाइक स्ट्रक्चर होता है वो स्ट्रक्चर भी तो फिर रॉन्ग हो सकता है ना
नहीं वो तो टोटली डिफरेंट है वो कनेक्शन डिफरेंट है वो डिफरेंट नहीं है मतलब वो स्ट्रक्चरली डिफरेंट है ना कि आपने उनके एंड्स जोड़ दिए बट दैट इज नॉट गोइंग टू बी एन आइसोमर बिकॉज the number of hydrogens are going to be different. For an isomer, the molecule, the number of atoms should remain exactly the same. Structurally, they were different. It's 5 carbon atoms in a cyclic structure, 5 carbon atoms in a straight line. Isn't the structure different? Isn't the bonding different? Different, है ना?
Yes.
So, but they're not going to be isomers because the number of atoms would vary. If I draw a cyclic structure, I'm going to come to that later. Okay. So the point is, I'll draw another one. Okay. Let's say I have another molecule, and this one has 5 carbon atoms, right? In this order. What is this similar to? Is this an isomer or not?
No, sir.
Okay, and this is exactly the same as the first one. Okay, they're exactly the same. So that is also not an isomer. That's exactly the same thing. So make sure it has to be structurally different. The direction doesn't matter. You can draw a bent version or a twisted version or rotated version, but you can't draw that twice. You can't draw a twisted version of the same molecule. The carbon atoms can point in any direction you like, as long as the arrangement is different. Is this clear? Is this clear to everyone?
Yes, sir.
Yes, sir.
So we can do 6 carbon atoms. Let's try and do 6 carbon atoms. How many different ways can I have 6 carbon atoms arranged in? That's 6 carbon atoms. So that's you can have 5 carbon atoms, and 1 carbon atom could be a branch. Then the same one, I could put that 1 carbon atom in this position, right? Or what else can I do? I can have 4 carbon atoms in a row, and I can have 2 carbon atoms as branches. Or I can do is I can have 4 carbon atoms, and 1 carbon atom could be over here, and 1 carbon atom could be over here. Then what I can do is I can have 3 carbon atoms. Okay, now this 3 carbon atoms and 3 more, right? So there could be 2 carbon atoms over here and 1 carbon atom over here. So this one, is this an isomer, the last one that I drew? This one over here.
So yes.
Is it a different isomer? ये ऊपर तो
So
इनमें से
लेकिन वो लीनियर चेन में ना तो
लीनियर को तो छोड़ दो लीनियर क्या से बीच में आ रही है उसको तो छोड़ दो मुझे बताओ इज इट डिफरेंट अरेंजमेंट और नॉट
No,
Yes,
sir.
a different range.
Nahin, these two are exactly the same.
Okay.
It's 1, 2, 3 carbon atoms, and on the third one, there's 3 other carbon atoms attached. This is exactly the same. It's 1, 2, 3 carbon atoms, and on the third one, there are 3 other carbon atoms attached. It's just a rotated version of the same one. It's like if I pick this up, so and I just rotate this, right? It looks, these two now look exactly the same. It's just a rotated version. So that's not an isomer. And I can probably not draw any other isomer. Anything else I draw, it would kind of be the same. It's going to be one of those above that we have already drawn. So there are going to be 5 isomers. Anything else drawn would just be a twisted version of the same thing. Okay, so you won't get any more isomers. Let me just confirm that's 5.
So,
Huh.
sir, इससे related कोई tricky question आ सकता है?
हाँ, इससे बहुत tricky questions आते हैं. Isomer questions are the trickiest. Because you have to, it's isomer questions are like really difficult in the sense that the problem with isomers is that if you're trying to make isomers, it's very easy to get things wrong. And a lot of times I'll do an isomer question. But okay, let me just go over this very quickly, and then we'll do a structural isomer question. So let me do the other one. Is chain isomers clear? Is this clear?
Yes, sir.
Okay, now positional isomers. Positional isomers are again a form of, this is part B's, the second type of structural isomers. Positional isomers are kind of easy because you just change the position of one particular group. That's it. You change position of any group. And you get a different arrangement. So for example, if I have 4 carbon atoms, I'm not going to touch the carbon chain now. Let's keep the carbon chain fixed. Now there's an OH attached. OH is attached over here. Another isomer could be that, another positional isomer could be that I could have the OH attached on the second one. So that's going to be a different arrangement. So that's what a positional isomer is. You just change the position of one of the groups. I can't change the position a third time. I mean, that's not possible. Like if I change the position once more and bring the OH over here, is this a new isomer or is it the same one that I've drawn previously? This one. Okay, is this new or different?
So what was your question?
Okay, is this an isomer or not? Is this a new isomer that I've drawn or not?
Yes, a new isomer.
No, these two are exactly the same.
Yeah, just a positional difference in Kara.
No, there's no difference. There is absolutely no difference. First, second, third carbon atom, there's an OH. First, second, third carbon atom, there's an OH. They are exactly the same. Bas ulta kiya hua hai, that's it. Clear? These two are exactly the same.
Yeah, okay, sir.
So that's not an isomer. That's just a rotated version of the same thing. You just flipped it around. That's it. So this one is not an isomer, and the same goes for any group. You can change the position of any group, and you'll get an isomer. Same thing. If I have a butene molecule, I've got a double bond. I can change the position of the group. And that's my isomer. Okay, that's a different arrangement. But I can't put it now on the first one. Why? Because these two would be exactly the same. Okay, these two are just flipped around versions. So that's not an isomer. Is that clear? This thing?
सर
yes
सर तो जो आपने लाइक ये जो 4 कार्बन्स का जो आपने चेन बनाया है जो लेफ्ट साइड पे
ये
या
वाला
फॉर या तो
हाँ
अगर इसका आप आइसोमर बनाना चाहे तो आप कैसे लाइक उसको बनाएंगे, क्योंकि हम लोग रोटेटेड भी नहीं बना सकते, बेंट भी नहीं बना सकते।
नहीं तुम कार्बन चेन की बात कर रहे हो
या सर के लाइक वो एक्चुअल आइसोमर हो उसका, इस मॉलिक्यूल का।
तो ये एक्चुअल आइसोमर ड्रॉ कर रहे हैं ना क्वेश्चन ही मुझे समझ आया हम कौन सा आइसोमर ड्रॉ कर रहे हैं हम एक्चुअल आइसोमर ड्रॉ कर रहे हैं
नहीं नहीं सर, लाइक आपने बताया कि लाइक रोटेटेड वर्जन भी नहीं होगा, बेंट वर्जन भी नहीं होगा, तो लाइक इसको कैसे फिर ड्रॉ करना चाहिए?
किस वाले को इसको
या सर ये जो सिंगल बॉन्ड वाले जिसके ऊपर थर्ड कार्बन के ऊपर OH बना है।
तो ये आइसोमर है ही नहीं ना मतलब इसको ड्रॉ करना ही नहीं है क्योंकि ये हम ड्रॉ कर चुके हैं पहले ये और ये एग्जैक्टली सेम है तो मैंने इसको दोबारा ड्रॉ क्यों करना है
ओके सर।
मतलब इस ये जो चीज ड्रॉ की थी ना दिस इज एग्जैक्टली द सेम उस यू पिक दिस मॉलिक्यूल इसको उठाओ इसको उल्टा करके रख दो तो मतलब इसको इसको उठा के ना उल्टा करके रख दो तो यही चीज नहीं बन जाएगा
या सर।
मतलब इसको इमेजिन करो ना यू पिक दिस अप और इसको यू फ्लिप इट अराउंड ठीक है जैसे हम रोटी नहीं उल्टाते ठीक है यू फ्लिप इट अराउंड सो इट वुड लुक एग्जैक्टली मतलब वो उस साइड पे चला जाएगा so that means you it's the same exact molecule it's just a different way of looking at it so that's not an isomer that's exactly the same molecule it's you're drawing the same molecule is that clear
या सर।
उसी तरह मतलब यही हमने यहाँ पे this is the same thing I did over here कि this was not we drew this and I told you this was not an isomer because we had already drawn this जो चीज आप पहले ड्रॉ कर चुके हो why are you drawing this again ठीक है I mean we the only thing was that we drew it in this direction like we had rotated it when we were drawing it I said ke have 3 carbon atoms in a row 2 carbon atoms over here there's 1 carbon atom at the top right but then that was not an isomer because this thing and this thing were exactly the same the only thing that you did was ke you picked the first one and you just rotated it that's it so I mean these two are exactly the same so that's not an isomer because you've already drawn this okay is that clear
यस सर।
और वही इशू था कि so what I meant was कि if you draw a molecule and then you draw a twisted version of the same molecule, it's the same thing. It's not something different. मतलब ये draw करने की जरूरत ही नहीं है क्योंकि you've already drawn this. ठीक है this one and this one are exactly the same. ठीक है there's no difference between them. So there's no point drawing this one. या तो ये draw कर लो या ये draw कर लो. Either draw one of them. It's they're basically the same. ठीक है idea clear है?
या सर।
तो मतलब वो है ना कि अगर मैं खड़ा हूं ना कोई मुझे कहता है हाथ नीचे करके खड़े हो एक और पिक्चर कोई लेता है वो कहता है हाथ ऊपर करके खड़े हो दोनों पिक्चर्स में मैं ही हूं ना तो मतलब वो मेरे इधर से सी नीचे की तरफ गया हुआ है सो उससे क्या फर्क पड़ता है इट्स द सेम थिंग इट्स जस्ट अ ट्विस्टेड वर्जन ऑफ द सेम थिंग सो दीस टू आर एग्जैक्टली द सेम ठीक है तो दैट इज नॉट एन आइसोमर अच्छा लास्ट वन कर लेते हैं दिस इज फंक्शनल ग्रुप आइसोमर्स आर कि you change the functional group altogether. Now, in functional group isomers, you've got, as the first thing, you can either alter the carbon chain, rearrange it in some other way. That's an isomer. You can either change the position of a certain group, like if the OH is attached on one at the end, you can put it at somewhere in the middle. The double bond is in the middle, you can put it at the end. So you can change the position of a certain group. Functional group is isomers are that you change the functional group entirely. You just completely change. हाँ
सर लाइक वो क्वेश्चन है कि आपके जो पास पेपर की सेशन होगी सैटरडे को, तो
हाँ
उसमें आप ये उसके लाइक पास पेपर्स में ये आइसोमर्स वाले कर सकते हैं क्वेश्चंस?
वो तो हम अभी भी कर सकते हैं
ओके सर।
वो भी करेंगे ना अभी तो हम बस डिस्कस कर रहे हैं अभी ठीक है कि ऐसे क्वेश्चंस होंगे भी मुश्किल ठीक है आइसोमर्स आर काइंड ऑफ डिफिकल्ट इट्स अच्छा carboxylic acid and esters are functional group isomers like if I have a molecule and it's a carboxylic acid So I've got double bond O and OH. So this is H, this is H, this one is and you've got C3H6 O2. So I'm looking for 3 carbon, 6 hydrogen, and 2 oxygens, another arrangement. Another arrangement could be an ester. It could be double bond O could be in the middle. And there could be 3 hydrogens. And 3 hydrogens over here. So these two are functional group isomers because the formula remains exactly the same. The structure is totally different. And the reason the structure is different is one of them is a carboxylic acid. The other one is an ester. So you've completely changed the functional group as well. So these two are isomers of each other, that you can rearrange the atoms in a way that the functional group changes. So that would be known as a functional group isomer. And there are many versions of this. Like you can have carboxylic acid and esters. You can also have aldehydes and ketones. They can be isomers of each other. If you've got an aldehyde and you've got a ketone. So aldehydes were that the double bond is right at the end. And this one has and a ketone was that the double bond is going to be in the middle. Both of them have exactly the same formula. So both of them are C3H6N and O. This one is also C3H6N and O. Both of them are C3H6 and O. One of them is an aldehyde, the other one is a ketone. The arrangement is different, the structure is different, but the molecular formula is exactly the same. So aldehyde and ketones can be functional group isomers of each other. Is this clear?
Sir? सर तो लाइक ये काइंड ऑफ सेम थिंग नहीं होगा क्योंकि वो एक एंड में आ रहा है और ये एक ही मिडिल में आ रहा है तो
लेकिन वो फंक्शनल ग्रुप डिफरेंट है ना. हमने पहले पढ़ा था कि we did कि if you have an aldehyde, the aldehyde is when the acetyl bond is at the end. Ketone is the acetyl bond is in the middle. So the functional group changes. I mean, they're two different functional groups. ठीक है? अच्छा इसी तरह you can have alkenes and cyclic alkanes. They can also be isomers of each other. Like if I have 3 carbon atom and it's an alkene, so it's C3H6. So this one is C3H6. A cyclic alkane can also have exactly the same formula. This one will have so both of them are C3H6. So they have the same molecular formula, but they have different structures. And the reason they have different structures is that their functional groups are even different. This one is an alkene. That one is not an alkene. So remember that when you're changing the arrangement of the atoms, you can also change the functional group. So you can, if you alter the functional group, if you have a carboxylic acid, what you can do is you can either turn it into an ester. Actually, you can do it. You can do other variations. You can change the functional group. You can make it into an aldehyde and an alcohol. Like you can keep the double bond over here, and you can take the OH somewhere else. So it's still the same molecular formula, but different arrangement. But this one is also a functional group isomer because what you did was you changed the functional group. Instead of a carboxylic acid, you now have double bond O. That's an aldehyde, and you took the OH somewhere else. That's an alcohol. So this thing is an isomer of this thing because it's the same number of atoms, except that they're arranged differently. These two are isomers of each other. It's you change the functional group. You had an aldehyde, now you turn it into a ketone. Alkenes and cyclic alkanes are also isomers of each other. So they're just some of the examples. ठीक है? So remember, just very quickly, I'm just going to recap this. We'll do more questions later on. We're basically done with structural isomers. The only thing is we just need to practice this. So first thing, if they ask you to draw a chain isomer, change or alter the carbon chain, make sure you don't do this. Make sure that you don't draw the same molecule over and over again. Like this has already been drawn. No need to draw this again. No need to draw a twisted version of the same molecule. Like this one and this one are exactly the same. I mean, no need to draw this again. So you can alter the carbon chain. You can either, if they ask you for the positional isomer, then what you can do is you can keep everything the same, just take or put the position of one of the groups in some other place. And the third one is you can just change the functional group altogether. As long as the number of atoms remain exactly the same, the arrangement is different, it is an isomer. So there are three basic types of isomers: positional, chain, and functional group. Is this clear?
Yes, sir.
So we'll do questions on this. Tomorrow probably I'm going to take a past paper class. I'm not going to discuss this. Tomorrow I'll probably take a past paper class. So it's not over. We'll discuss a lot. We'll do past paper questions on this. And especially on structural isomers. Questions can be difficult because I mean there's so many combinations that you can very easily miss a few of them. So we'll try and do the questions tomorrow. So okay everyone.
Sir,
हाँ जी.
सर वो above वाला part दिखा सकते हैं आप?
ये दे लो. It's मैं दिखा देता हूँ. You can take this board link as well.
No sir, like वो उसके अंदर like आप कह रहे थे कि एक
अच्छा.
दफा आइसोमर बना लिया तो फिर बार बार बनाने की जरूरत तो नहीं पड़ेगी ना, आपने कहा था इस तरह.
तो मैं वो कह रहा था उसको फिर से समझो. ये अगर बना लिया है ये वाला, और फिर तुम दोबारा वही बना रहे हो उल्टा करके, तो मतलब क्यों बना रहे हो? मतलब वही चीज दोबारा क्यों बना रहे हो?
Yes sir.
मतलब ये अगर मैंने बनाया ना, लेट्स से ये बनाया, ठीक है, मैं जो समझाने की कोशिश कर रहा हूँ ये बनाया, उसको तुम दोबारा बनाते हो और उसको इस तरह करके बना देते हो, तो ये तो वही चीज बना दी है तुमने, दोबारा बना दी है.
Yes sir.
मतलब मैं ये समझाने की कोशिश कर रहा हूँ भाई, तुमने अगर एक दफा बना दिया ये, तो उसको दोबारा क्यों बना रहे हो? क्योंकि वही चीज तुम दोबारा बना रहे हो, बस उसको उल्टा करके, उसको टेढ़ा मेढ़ा करके बना रहे हो. यू जस्ट ट्विस्टिंग इट, यू जस्ट रोटेटिंग इट. तो मतलब वो एक दफा बना दिया तो उसको दोबारा बनाने की जरूरत नहीं है. इट्स नॉट गोइंग टू बी काउंटेड एज अनदर आइसोमर. समझ आइए कि अगर वो तुमसे कहते हैं ना 2 आइसोमर बना दो, तुम ये बनाते हो और तुम ये बना देते हो, तो तुमने 2 आइसोमर्स नहीं बनाए, तुमने वही चीज उठा के दोबारा टेढ़ी करके बना दी है. समझ आइए?
Yes sir.
तो the point is कि अगर if he says कि draw 2 isomers, so that is one, that is the other one. ये बनाओगे और फिर ये बना दोगे तो वो तुमने एक ही बनाया है, तुमने 2 नहीं बनाए. ठीक है, ये बेसिकली था कि ट्विस्टेड वाली जो बात थी ना, this is what is meant. या फिर तुम ना ये उसको और थोड़ा टेढ़ा कर देते कि लेट्स से अरेंजमेंट चेंज ना करते, जो सी है ना यहाँ पे, इसको उठा के थोड़ा सा टेढ़ा करके उधर ही लगा देते. ये अभी भी आइसोमर नहीं बना, इट्स स्टिल एग्जैक्टली द सेम थिंग. तुमने बस इसी को पकड़ा हुआ है, उसी को तुमने थोड़ा सा टेढ़ा कर दिया, ट्विस्ट कर दिया. इज दैट क्लियर? दैट्स स्टिल नॉट एन आइसोमर.
Yes sir.
तो ये मैं एक्सप्लेन कर रहा था कि ये नहीं करना. when you want to make an isomer, it has to be a totally different structure. It has to be a totally different arrangement. ठीक है? It should not be a twisted version of the same thing. Clear?
Yes sir.
So let's talk tomorrow. Tomorrow I'll probably have a past paper class. We'll not do this. We'll do this on probably Thursday then. Okay, let's continue tomorrow. Okay, everyone. Take care. Allah Hafiz.